Okay, chapter 7, right triangles and trigonometry. This chapter has a lot of new information, but we're going to cycle back to talk about the Pythagorean theorem first. So Pythagorean theorem only works for right triangles. The A and the B side are the legs, or the two sides that make up the 90 degrees. The C side is the hypotenuse, which is directly across from the 90 degrees. We've seen this before. These are the legs. A and the B is the legs. C is the hypotenuse. The C side is always the longest side. You should know that also. Looking at an example, and we have done quite a few like this, so this should be pretty simple for you. Find the unknown side length and round to the tens place and show the simplest radical form. I'd like you to show both. So looking at our picture, we have both the legs, but the hypotenuse is one that is missing. So when I plug it into the Pythagorean theorem, I have 6 squared plus 5 squared equals x squared. These two are interchangeable because we know we can add in any order. So 5 squared plus 6 squared means the same thing. Square both numbers. 36 and 25 gives me 61, and my last step is to square root to get x by itself. This is where I want two different answers. So when I plug this into my calculator, I get 5.8. That's our rounded answer. Simplest radical form I want also, just for good practice for you. 61 is in simplest radical form because there's no perfect square factors that go into it. 4, 16, 9, 25, those do not go into 61. So that's simplest radical form. And I do want you to show both of these kinds of answers. Area of a triangle, that should be reviewed for you also. 1/2 times the base times the height. It's important to note that the height has to be perpendicular to the base. So when you have different kinds of triangles, be aware that sometimes the height could be outside the triangle. Looking at an example here, this is more of a complex picture, and because we don't want to use a formula that fits this entire shape, we're going to divide it into two triangles. So what I did was I divided it into this triangle here and this triangle here. So I found the area of both of these triangles and then of course added it together. So concentrating on this triangle first, I know that the base is 13 and the height is 4. Again, that height has to be perpendicular to the base. So very simply, 1/2 times 13 times 4, the area of that triangle is 26. The other triangle over here, the base is 3 and the height is 4 because these two lines are going to be the same. So again, 1/2 times the base times the height gives me 6. Add those two areas together, the area of that entire figure is 32 inches squared. Make sure that when you're finding area, you have to have units squared. That's important. Pythagorean triples, this is new to you. Pythagorean triples are just 3 numbers that work for the Pythagorean theorem. And that means that there's no decimals, which you guys should like to hear. Common Pythagorean triples that you've probably seen before, 3, 4, 5, I can guarantee you've seen that before. That should sound familiar. So 3 squared plus 4 squared does give you 5 squared. It makes that equation work. 8, 15, and 17, 18 squared plus 15 squared does give you 17 squared. Again, it works in that equation. If you Google this, you can get a long list of Pythagorean triples. I'm not asking you to memorize them. Just be familiar with them because it can shorten some time on some problems. Take a look at some of these examples. This is a little bit tricky. We're using the idea of Pythagorean triples to find an unknown side. So look carefully at the directions. It says the given lengths are 2 sides of a right triangle. So we know that it's 2 sides. We don't know if it's 2 legs or if it's a leg and a hypotenuse. All 3 side lengths are integers. That means that there is no decimals. And together form a Pythagorean triple. Find the length of the third side and tell whether it is a leg or hypotenuse. So here's my first example. You're given 40 and 41. You have to figure out what the missing side is. So the first thing I did is I'm going to pretend that both of these are legs and see if it works in the Pythagorean theorem. Again, I'm looking to see that it doesn't have any decimals. So when I plug it in as 2 legs, remember this is A and this is B, and I simplify, if you follow what I'm doing here, 1600 and 1681, add them together, got 3281. Square root both sides, I got a decimal. So that tells me that this scenario does not work. So I'm going to do the other scenario. So I put in, this needs to be fixed here. This should be 41. I put in 40 as a leg and 41 as the hypotenuse. Again, I squared them, subtracted 1600 from both sides, and when I square root, I get 9 as an answer, which is not a decimal, which tells me that this scenario does work. When this is a leg and this is a hypotenuse, I get a whole number, not a decimal. So this works. So the missing side is 9, and 9 is a leg because it's the B. Let's look at one more example. The two numbers that are given to you is 28 and 45. Again, we're looking for the unknown side, and we have to figure out if it's a leg or a hypotenuse. I have a habit of always trying both legs first, but that's up to you what you want to try first. So I plugged in 28 squared, 45 squared equals c squared. I want to see if this works. Squaring them first, and then of course square rooting last. When I square root 2,809, I get 53. Because it's not a decimal, that means this scenario works. And because 53 is C, that means 53 is the missing side and 53 is the hypotenuse. So we can say 28, 45, and 53 is a Pythagorean triple. Be careful with these. If you look at my examples and when you do these on your own, you should be able to handle doing these problems. And here's your homework.